Today we're going to be doing the capacitance experiment. The purpose of this experiment is to investigate how the capacitance of a parallel plate capacitor varies when the plate separation is varied and when the dielectrics are introduced between the plates. There are many different types of capacitors. There are cylindrical capacitors, spherical capacitors, and etc. But today we're going to be using a parallel plate capacitor. A capacitor is used to store charge and can be made when any two conductors are separated by a distance d. This is shown by the equation capacitance is equal to the dielectric constant K times epsilon 0, which has a value of 8.85 times 10 to the negative 12 Faraday per meter, multiplied by the surface area, divided by the distance between the two plates. The equipment of this experiment includes a Pasco electrometer, a Pasco capacitor, a 6-volt battery, some leads, such as these, and paper, a stack of paper that will be used as a dielectric. For this procedure, the diameter of the parallel plate capacitor is given as 18 centimeters. So what you're going to want to do is you're going to want to find the area of one of the capacitor plates by using the area of a circle. You're going to notice that there are 3 plastic spacers on the movable plate, which when you put the plates together, the distance between the plates is going to be 1 millimeter. Now you're going to want to make the plates parallel to one another, and you're going to do this by adjusting the knobs on the fixed plates so that the distance between the plates is even throughout the whole thing. And after you do that, you're going to move the plates so that they are 2 millimeters apart, and then turn on the electrometer. After you turn it on, you're going to want to set the range to the maximum, which is 100, and you're going to zero it. Then you're going to connect the battery to the capacitor by connecting the negative side to the negative side and the positive side to the positive side. And when you do this, be careful not to touch the plates because you could discharge it. So after you connect it, the plates are charged. So take off the leads from the capacitor, and then you're going to want to start moving the plates so that they are increasing distance, and at every distance you're going to want to record the voltage between the two plates that is recorded on the electrometer. Once they are about 12 millimeters apart, you're going to stop and find the capacitance at each distance using this equation where K is equal to 1 because it is an air. Once you do that, you're going to use this equation and find the equivalent capacitance C prime by using C sub 0, which is 35 times 10 to the negative 12 farad, and adding it to the capacitance you found earlier. Using this data, you're going to construct a graph, voltage versus the reciprocal of C prime, and the slope of that graph is going to equal the charge. For this procedure, you're going to find the dielectric constant. You're going to take a thick bundle of paper, about 1 to 2 centimeters thick, and you're going to place it in between the plates so that it fits snugly. And you're going to take the voltage in between them that is shown on the electrometer, and then very gently you're going to remove the paper and take the voltage without the dielectric. And then you're going to find the dielectric constant by dividing the voltage without the dielectric by the voltage with the dielectric. And you're going to repeat that experiment about 2 more times using different thickness of paper. The dielectric constant K should be around 3 to 3.5.